Well, I am delighted to welcome our next speaker, Jacob Lee. Jacob here is a seasoned software engineer and a serial entrepreneur. He's currently the lead maintainer at LangGraph.js. And let me tell you, he's got a huge appetite for learning, for teaching, and apparently omelets. He once ate 18 omelets and a full pack of bacon in one sitting with a friend.
18 eggs. Thank you.
Yeah. With all the protein in him is Jacob Lee.
It was a long time ago. Unfortunately, have better habits nowadays. Thank you, Daphne, for the awesome intro, and hopefully everyone's having a great conference so far. So, like Daphne said, my name is Jacob Lee, and I'm the lead maintainer for LangChain.js. If you're not already familiar with LangChain, we help developers build with LLMs through our open source Python and TypeScript frameworks that simplify orchestration. We also have a platform, Langsmith, tailored toward the unique challenges LLMs present around debugging, evaluation, and generally productionizing apps. So I'm here today to talk about building useful apps with small LLMs and LangGraph.js, our framework for building agentic workflows specifically. But first, the million-dollar question, why? After all, we all know that when it comes to LLMs, bigger is better, right? And for example, consider this query I ran with GPT-2, the open source predecessor to OpenAI's GPT-3. The model is light and small, but when I ask it a simple question, like, how are you doing today? You get a slightly deranged response, let's say. The best way to ensure that you're doing today is to give your children an active role in the classroom, in the classroom, in the classroom, and the classroom. Which, it's technically English, and I may or may not be grammatically correct. Been a while since I took English class. But it's not really anything that's gonna, amaze, let's say. And a big part of this is because it's a 85 million parameter model, which is really, really small by today's standards. I think you can run models 1,000 times or 10,000 times more powerful pretty easily on advanced Macs. So big models obviously are bigger is better to a degree, but small models do have some advantages, and there are good reasons to keep them in mind when building. So here I've run the same query twice, once with GPT-4 and once with GPT 3.5 Turbo, which many of you are probably aware of. And you can see that the smaller model ran in about 20% of the time, 3 seconds versus about 15, and with a big cost advantage as well. Another advantage is portability. Large closed-source models are hosted behind APIs. While you can run small LLMs from your laptop using tools like Ollama, which is a really fantastic desktop app, which I'll be using to build and show off a bit later, or even in the browser using tools like WebLLM. That's right, in the browser. Wasm magic. And it also means you don't have to worry about OpenAI board drama ever again. And finally, using small models really forces you to think about what you're doing. Relying too heavily on the reasoning capabilities of powerful models can lull you into a false sense of security. They let you get away with simpler architecture, which can bite you if you're not careful. And the consequences can be not so great. Awesome, so hopefully you're convinced, and if not, hopefully you'll be convinced. But then where do you start, right? Raise your hand if you found yourself unable to keep pace with the kind of rate of progress in the LLM space these days. And yeah, don't worry, it's my job to stay as tuned in as I can, or at least part of it, but I often feel that way too. So here's my quick overview of the current LLM landscape. And in the beginning, there was the, of course, seminal paper, Attention is All You Need, which introduced the concept of the transformer, the architecture that underpins modern LLMs. And that was June 2017. Over the next few months and years, OpenAI created GPT-1, February 2018. A year after that, GPT-2, GPT-3, which I'm sure most of you have heard of by this point. And it's worth looking at the date there, June 2020. GPT-3 came out 4 years ago now, and we're just hearing about all this stuff now. So when you hear about kind of this progress, a lot of this has been kind of going under the radar and like has been shipped quickly as people have sort of gotten this huge demand for it. Progress continued steadily, with those in the know playing with things like Dolly for image generation, GitHub Copilot for code, GPT 3.5 Turbo in March 2022. And then everything changed when ChatGPT launched and captured the imagination of everyone in the world. It was just pure magic to folks. And suddenly everyone was interested. Became like a meme almost. And over the course of the next 2 months, Anthropic launched Claude 1, which is kind of a solid alternative to GPT 3.5 at the time. OpenAI shipped GPT-4. We started seeing these really interesting trends around open source models too that started to emerge as people wanted to demystify behind the API. You had GPT-4 all from Nomic, which is kind of the first one you could really run on a laptop. It was pretty hard to set up back in the day, but it was there. The first Llama model from Meta, Bloom from Hugging Face, and a few more. And since then, the world's kind of gone crazy. There's been new players all over the place. Llamas and Gemmas and Groks, 2 Groks, in fact, neither of which are spelled the same. Google kind of showed up in earnest. They obviously, or for those that don't know, the original Transformers paper was written by a few researchers at Google Brain, and OpenAI has been shipping vision models like 4V and the 4 Omni or 4O. Still not really sure. Cloud providers like Azure and AWS have made enterprise use more palatable. You have Mistral, Cohere, Llama 2, Llama 3, Phi 3, which, shout out, is a excellent, very small model, 80 times smaller than Elon's Grok, which you can see the X there is a massive 314 billion parameters. And literally today, in fact, Anthropic released a new state-of-the-art model, also 3.5. People don't really seem to have much creativity. That made me update a few of these slides, claiming some pretty outrageous benchmarks. And any guesses as to what's next, Q3 2024? Well, my extremely serious and very educated take, and you can quote me on this, is that we'll have an open source Llama 3000 next quarter. That begins a true AI revolution, and I'm, of course, talking about Skynet. Now, all joking aside, the question remains, with this fast rate of progress, how do you know what model to pick? How do you know what's actually good for what you're trying to build? And evals are important, but it's also important to stay flexible. And given the rate of change, it's really too early to build for a specific model. You should instead focus on productionizing and architecting your models well, or your apps well, rather. Just because these models are kind of like God engines or whatever, it doesn't mean you can forget how to write tests. All that's still important. Every little bit of kind of good software practice remains pretty important. And this is really what I'll be talking about for kind of the rest of the talk, is how do you build well and build with futures in mind. And again, going back to my original thread, there are some limits. This GPT-2 example, is probably not going to be, you can't really squeeze water from a stone too much. And it's just a little bit too derpy. So there is some lower limit, and maybe that limit gets lower over time, but you do want to be a little bit, you can't expect miracles from just any model. So a good way to pick is evals, and I would encourage you all to run your own and sort of learn and see, go through the process of curating a data set and sort of get a good kind of way you can gain confidence in what you're building. But this, if you're a little bit lazy, there's some good rankings out there. This is one from Hugging Face. It's a chatbot arena leaderboard that some folks have put together that uses ELO. And basically, you can go to this app and do a blind side-by-side comparison of 2 different outputs using the same prompt from a given model. And if you ever played chess or games like that, and you can get a sort of global ranking from this pairwise comparison. And from what I've seen, it matches pretty close with my own intuitions and what I've seen. So a couple to note here: GPT-4o is at the top. Again, Anthropic just released a big kind of supposedly state-of-the-art one that seems to have performed really well. So this is already perhaps out of date. And you see your first open source models. Yi is by a Chinese consortium, I think, company. That's currently the top open source model rated here. You have Llama 3 70B, which is kind of a medium big model. I can't run 70B on my laptop. It's only 16 gigs, but you could run it on a relatively powerful M3. And then if you go to the next page, we get to some that are like kind of more reasonable for you on like most people's consumer hardware. And we see here Llama 3 8B, which I can run comfortably on my 16 gig M2, and I think you could even do if you had 8. Haven't tried myself. But the amazing thing here is that this 8 billion parameter model that you can go download or pull from Hugging Face or just directly from Meta, actually on this, by this one metric, outperforms the original Claude 1, which if you remember was only, I forget what I said, I won't go back, but it's a year and a half old or 2 years old at most. So just let me underscore that. You can run a model right now that has a better kind of chat-like response than what was like pretty state-of-the-art two years ago or a year and a half ago, maybe. Awesome. So hopefully that gave you a little bit of insight on how you might pick models and how you might evaluate. But the question remains, how do we build a model? And this is a graphic I really like. We've been looking at this a lot with LangChain. We think of autonomy as kind of a spectrum. So at the very top, you have code, which I assume, raise your hand if you don't know what code is. How about that? Oh, we got one joker over there. So when you write code, generally, if your code isn't doing something consistent, like consistently working, let's say 99.999% of the time, like you've probably done something very wrong, right? Like you have a bug, you need to go fix it. There's some hopefully nothing deeper. But you, the programmer, are deciding at each step what you want to do. You have some control over like the output. You can reliably unit test, and you are planning the course you want the execution to take. Then you have a single LLM call, and this is sort of your ChatGPT, right? It's just going to go. You are still deciding what prompt you want to send it. You're still deciding like what you do with the output, but you're not entirely in control of what's being output. By the way, like there's like text SQL use cases that people have really embraced, but you need to be careful, right? Because it could theoretically there's nothing really stopping from generating like drop tables or something. So there's some care needed, but at the end of the day, you do still have a fair degree of control. Next, you have chains, which we call like sequences of model calls, which you still, again, you're controlling. You know when you're calling it, you know where the output's going, but now you have like more degrees of randomness in that like it's not just one model call that you have to worry about and sort of evaluate and sort of test. You now have several that you're treating as a unit. Routing is a step above that, where you're actually having the LLM make a decision on which path to take in execution next. So that's a really basic form of like what we call agentic behavior. But again, the developer, is still determining what's available and like what the LLM can do. You just have even a little bit less determinism around what execution's taking. And then we get into like kind of the interesting stuff, which is where you're giving the model a lot more power. And this is we're going to get a little bit more into this later, but this concept of a state machine where now you can have cycles. So you don't actually even know, theoretically the LLM could keep routing around the cycle and like you don't even know if it's going to terminate. And you can get a lot more power, but also it becomes a lot trickier and you need to be a lot more careful when writing. And at the bottom you have like kind of full-on auto, like AutoGPT, Baby AGI, all those cool demos you saw way back in a few years back when the LLM was just really picking tools at random, or hopefully not at random, but picking tools and just running with them. So for folks who have heard of LangChain, a lot of what we have with the kind of base open source framework falls in these first three categories. I mean, I guess technically the first one too, because it is code, but mostly is centered around this idea of chains with some basic routing. And with LangGraph and what we're doing now, we're moving a bit more towards this like state machine approach where you can get like really, this agentic behavior unlocks a lot, right? You can sort of have like these non-intuitive leaps that like can deal with like different, more unstructured types of data at the cost of more control. But if you define your states well and like you kind of lay out your logic nicely, you can get around and sort of, let's say, define some good outcomes more easily than you would with just like a full-on auto model call. And don't take my word for it. If any of you have any ML background, you might know of Andrej Karpathy, who recently left OpenAI, but was responsible for a lot of great advances there. And he kind of coined this term flow engineering, which sort of illustrates the exact point where you have different prompts that like sort of, you take the output of one and use it to like refine like some state in the middle and kind of improve over time. And yeah, this is where LangGraph comes in. So it lets you kind of do just that, where you, again, think of your logic as like a series of nodes and edges, and each node represents some state that your LLM's in, and edges are transitions between that state. And this lets you do a lot of things over just pure, A to B to C defined states or defined chains. You can fully customize your what we call cognitive architecture, which is really just a fancy way of saying your architecture. And you can use it with LangChain modules or not, so all the integrations that you might have seen with LangChain. And it provides first-class streaming support as well. And at the center of it is this concept of state. So with this, different nodes themselves represent state, but you also have like some internal state that represents like the execution path that your code is taking. And what this lets you do is like it lets you give more context at any given node than you would if it was just like a, let's say, simple agent loop or something. You can change the prompt. You can use context from like the point of the execution you're in already. And LangGraph supplies some tools that you can use to debug and build. There's checkpointing for rewinding and debugging. You can also interrupt at certain points. So let's say you're building something that's consumer-facing, and let's say like a customer support bot. You probably would want to probably work in your finance team before you let the agent just start handing out refunds. So a nice way to do that is to just require authorization, or we call human in the loop. And then you get all these nice Langsmith features for productionization, debugging, et cetera. One nice thing about this is it's great for small models. So as I mentioned before, small models require a bit more focus and context to perform well. And you can tailor your prompts or other sort of like logic internally to do different things based on and be more focused based on like the point in the execution you're in. And you also get these nice debugging features that are vital for tuning individual nodes. You can see where something's failing or where something starts going off the rails and then start fixing it. And what I'm hoping to convince you is like with a bit of good architecture and good setup, this kind of gaggle of derpy models can approximate something really great. So let's go through an example. One more kind of show of hands. Who's familiar with retrieval augmented generation, or RAG? Okay, cool. So actually, not as many as I would have thought, which is great. This is good. The basic concept is that and actually let me go back so that's not too distracting. You have these LLMs that are trained on massive quantities of data, right? But all that data is stuck in the past, for example, or some of it's trapped in not trapped, but like hidden within organizations, or like some PDF in like a library, or PDF in a database somewhere, or a book, like old scroll in the Library of Alexandria or something like that. They don't know everything. And to get around that, what you can do is you can actually have some specialized database. DataStax is sponsoring the conference. They're one example that can pull, basically, you can load different portions of data into the database, and then they can like pull it out based on some metric. And usually that's like some query you want to answer, and they'll retrieve some documents that are most similar to what you're trying to answer. Hopefully that's relevant context to the sort of response and the information you're trying to get. And you use that retrieved document to augment the LLM's generation. So you tell it, this is like some information you already have, push it into the prompt, and then hopefully the LLM can intelligently answer with that in mind. And I kind of wish more people would raise their hands, because what I'm about to show you is not your grandma's retrieval augmented generation. So to start, we have this retrieval flow that I've mentioned, and where we fetch the documents from the data source. And we're going to add a step here that before presenting to the LLM as a prompt, within the prompt as context, we're going to judge each document for relevance, since sometimes this naive similarity search fails, or just you get false positives. The query is too vague. Sometimes, let's say you are querying for something like person, and you get the wrong kind of person. So by adding this filter step, we can focus the LLM, or we can focus the context we provide the LLM a bit more, and reduce the amount of distraction, which is especially important for small models. If you feed it bad things, you'll get bad things out. And then we can, one approach would be just go generate it after that. If we take it a step further, though, we can say add more steps that check for hallucinations on the final output. I'm sure many of you have heard that term before, or have seen that firsthand actually with ChatGPT, where it'll spew out nonsense or things that don't really quite make sense to what you're asking. And then you can do a final check for relevance, perhaps. So you can really sort of make sure that your answers are staying on track and on target. And then you can add some redundancy. So if you get maybe like a bad result, you can start over with like a new or rephrased version of the query that maybe retrieves different sets of documents, or slightly different sets of documents based on, hopefully you have better luck the next time at any rate. And we can even go a step further. So this would do hopefully well with a specific domain of knowledge. Usually you want to keep your ingested documents like pretty focused on one category or another. If you don't, then you can, again, if you just use naive similarity search, you can get into trouble where you get like documents from like other domains creeping into like the one you care about. So one way to get around that is to, and to make our chatbots even more flexible, is to use this concept of adaptive RAG, where RAG is, by the way, the acronym for Retrieval Augmented Generation, short, catchy, snappy. And there are many forms this could take, but basically we do at this initial step where we analyze the initial query, try to route it towards like one data set or another. In this case, it's going to route to a general like web search if we get a question that's not related to the task at hand. And yeah, with LangGraph, you can actually run this pretty effectively with local models too. So I'll be using, or what I set up uses Llama, which again is like a really convenient way to run these small open source models on local hardware. And Llama 3, which is a kind of state-of-the-art open source model, and then Transformers.js for the embeddings. So you've heard me talk a lot about architecture, and what's this like in practice? So we'll build a graph that can answer both deep technical questions about LLMs and agents, and that'll be our like primary data source. And we'll have it answer more general questions or irrelevant questions to that by falling back to web search. And this looks like something like this. This is like a sample document ingestion flow where we have like a couple of blog posts by an OpenAI researcher named Lillian Wang, and we're going to load that into, we're going to basically pull that from her blog, ingest it into a loader, and then we're going to do something called splitting, where these documents can be very long, and LLMs can only take so much data at a time. So we're going to split it into more manageable chunks, and then load it into our vector database. And here, this is the kind of loading and saving part. And we're also going to set up a Llama model that wraps Llama 3. And next, we get into the LangGraph pieces. I mentioned earlier, state is very important. So you can think of the state object as something that's like passed back and forth between different nodes and different edges. And this is like the information we want to kind of carry, and like sort of every node should have it, and all of the edges should have it as well. And it's going to be the question, whether rephrased or original, the generation, the current like candidate for final output, and then whatever documents we've retrieved or filtered at any given point. And the bottom bit is like a updater. So this is how we're going to update the state. And yeah, in this case, we're just going to have any return documents override what's already there. Let's dig into what a node looks like. And I won't go into all of them. There's a lot of them. But essentially, they can be pretty simple. This one is literally just retrieving documents from a retriever I've set up based on some question. And it returns that document. You remember the state is the kind of bit up there. It's just going to return like whatever it retrieved and like override whatever is currently in the state. Conditional edges. This is like kind of how the LLM knows like what the next node in the execution path should be. Take the state as well, but then also return the next node, essentially. So if you notice, it's all just JavaScript. You can use whatever you'd like in here. Then you lay out the graph by adding the nodes and then the edges. A little bit pressed for time, so if I'm going a little bit fast, I'll make the slides available somewhere. And then we'll compile the graph at the bottom, which finalizes it, locks it in. And we'll add this kind of cool extra step where, let's say I mentioned earlier, you have a customer support workflow where you want to have your finance team authorize refunds. I'll do a simple one here where we require authorization for web searches, because maybe we don't have so many credits or there's some other limiting factor there. Cool, so in action, it looks something like this. We're going to ask it, what are some features of long-term memory, which is a question related to agents and LLMs. And given the graph I've just set up, we'll run it. And this will be some thread ID that tracks the current conversation I'm in. You'll see how that plays in later. And it's going to go through, it's going to retrieve from the vector database. It's going to get some documents. It's going to filter some that are relevant and not relevant. It's going to say, OK, this is good. We have enough information to generate. And then it's going to get a final generation that looks pretty good. According to the context, some features of long-term memory include ability to retain and recall information. Kind of a pretty quality response for a small model. And we can see what's happening under the hood here. There's a lot of different node calls, model calls. This is a Langsmith trace view, which is pretty handy for debugging. You could actually go and click any one of these and sort of see and mess with the prompt. If you see like it's marked something as irrelevant that should be relevant, for example, and yeah, sort of like go through, play within the playground, debug, etc. And next, let's try asking something that is completely irrelevant. Where is CascadiaJS this year? So obviously we all know, so I wanted to pick something like that. And if I run it this time, given some other thread ID, that's like the current conversation state, we can see that it routes the question correctly to a web search and then stops. And then I have to actually invoke it again with like, basically, this is the authorization part I was mentioning earlier, where it'll basically pick up from the checkpointed state if it's approved, or you could have some other endpoint that sort of calls this. It's all pulled from some Postgres database or that stores the checkpointed information. And we get a good answer. It's CascadiaJS is located in Seattle, Washington, which is great. And again, you can see here, same trace view, where this is the first step where it's waiting for authorization. It only executes once and then returns. And then next, it does the rest and generates a final answer. Awesome. So if that resonated with any of you, selfish plug here, we're looking for one or two really great TypeScript engineers. So if you're interested in looking, or you enjoy working with LLMs and agents and new tech, please see me after. And I've got some links here. That's my Twitter, or X rather, at Hakubu. There's at LangChain.ai for more general LangChain updates. And then some resources for LangGraph.js, LangChain.js, Langsmith, and the full notebook I ran from the demo just there. And yeah, thank you very much for your time, and hopefully you all enjoyed.